Google Classroom classwork, the Gizmo's activity, open the document on one tab and leave it open, and have the Gizmo's website open on the other tab. So let's just give it a second to load. We will just talk about the different parts of the balance. Okay, and let's see, let's launch the triple beam balance. And over here we have 2 pages to work on. Very simple, plugging in numbers, getting the answers. So this is a triple beam balance. It works on the same principle as the seesaw in the park. Have you guys seen the seesaw in the park? The seesaw, that means one person sits on one side and the other person sits on the other side, and you balance it out. If you have the difference in weights, then the seesaw might go up and down. But if the 2 kids who are sitting on the seesaw have the same, approximately the same weights, so the seesaw doesn't move. It balances or keeps it straight. The same principle applies here. So the measurement tray, if you see over here, you keep your weights on it. And if you keep your weight on it, and the pointer on this side, that's the gray part, the pointer will go up. So it is disbalanced. And the 0 mark, which is right here on the beam balance, that needs to be aligned if the weights are equal. So these are the weights in the middle. They are also known as riders. You can slide them left to right. We have 3 different riders. I'll show you. But when we will talk about the balance, we will use these vocabulary words. Rider is something we will use very often. Pointer is another one, and the 0 mark is another one. So we will use these vocabulary words to communicate when we are talking. Okay, so all right, let's go to the balance. Be quiet. I'm right here. All right, so we have 3 different weights. Here. So we have 3 different weights. This is the 10-gram weight. If I move the 10-gram weight to a mark of 40, what happens to the pointer?
It goes all the way down.
That's actually the first question. I think it's about 100 grams, but let me just scroll up. Drag the 100-gram rider, but I just dragged the 10-gram rider to 40. What happens to the pointer? The pointer goes down. And if you move it back and you just move the 100-gram rider, which is in the middle, this is the 100-gram rider, the magnification of the pointer is right below the balance. So you can see much clearly. So if you move it to what number again? To 300. Sorry, to 300, then you can see what happens to the pointer. That's another question in the handout. It goes all the way down. Okay, that's the second question. Let's try to get the mass of any of these objects. Let's put the light bulb on it. So if you have to put the light bulb on it, what happened? This balance created the pointer to move all the way up. So first, which weight am I going to use if I want to find the weight of the light bulb? Any ideas? Which weight ideally should I start to move? No one? Someone? Should I move the 10 grams? Should I
The
move the
100.
100? The 100. Okay, let's move it. Nothing changed. 200, nothing changed. 300. What does that tell us?
That 300 is too much for it to be balanced, so now you have to move the tens.
So should I leave it on 300 or should I move it back?
You should move it back and then move the tens.
Okay, I'm going to, so that tells us that the light bulb is between 200 and 300. 200 is too light and 300 is too heavy. So we will try the tens weights, and we are at 40. The pointer is still up. Now at 50, the pointer has gone below the 0 mark. You see it here? It's below the 0 mark. So what does that tell us? The weight of the light bulb is less than 40 or more than, like it's between 40 and 50.
50.
All right.
50.
So I'm going to move it back to 40. And if I want to have the exact weight, I have to move the smallest weight, which is 1 gram rider. This is the last row. So I'm moving it. And do you see on the left hand side the red triangle and the magnification has come up?
Yes.
All right, so that would help us give a precise reading for the, so I'm moving the rider and the pointer, if I'm keeping my eye on the right hand side on the pointer, the gray pointer, is it aligned yet? Now the magnification has increased because we are about to reach the, am I good? Or no? Right there. Is it aligned?
Yes.
So what is the reading on the 1 gram scale, on the 1 gram rider? 5 point. Can somebody read it for me? The magnification of the red triangle is on the left-hand
5.6.
side. 5.6. Is it exactly on 6 or is it between 6 and 7?
Between 6 and 7.
So either you can leave it 5.6 or you can have 5.65 because it's between 6 and 7. So what would be the total mass of the light bulb? How are you going to find the total mass of the light bulb?
You add all the values of the riders together.
So it'd be
Thank you.
245.65 grams.
Yes, very good. So you have the answer to the questions on the second page. The mass of the light bulb is the sum of values of each rider. So the 100 gram is at 200, 10 gram is at 40, the 1 gram is at 5.65. You add up everything, the final answer is 245.65 grams. Do not forget the units. Units are very important. All right. So I just want to show you a couple of more things over here. In one of the questions, it asks you to take a screenshot, take a snapshot right over here. So there is, under the tools, there are a few options. There's an option of a screenshot. If you press this, the readings will be like a proof that this was the reading, this was the weight of the light bulb or any other object. You can take a screenshot from here. All right. So the tools can go back up, and on the bottom of this page, there are 5 multiple choice questions that you have to answer. So you have 2 things to do today. A very easy handout for the triple beam balance. It's 2 pages, and there are some multiple choice questions over here. You finish this handout, you finish the 5 questions below the gizmos, and then you can press this button, check your answers, and make sure you complete your exit ticket, and you're good for today.